close this one, right? Close this one. Go to the SK. So. Stream. Yes. Okay. Oh, มาแล้วพิมพ์ชื่อแล้วโอเคโอเคครับหมายเลข12มีanyway I have to send the link to send it to M604 604 then we close this one and you need to increase the volume this one has okay 13 okay okay hello good morning everybody can you hear me ทุกคนได้ยินไหมครับso that's everything okay I need to increase the volume and of course this Okay. Good morning, everybody. Welcome you formally to the SCI33205. Okay. So according to our agreement, you need to submit the homework before the lecture starts. And one thing I would like to inform you is that there would be a change in how we arrange the formative score or the formative homework. I'm not sure whether you can give me any response ขออภัยใช้เมลผิดครับไม่เป็นไรครับตามสบายครับดังที่ผมเคยแจ้งนะครับดังที่ผมเคยแจ้งเรื่องว่าจะเก็บคะแนนการเข้าเรียน15นะครับในส่วนของก่อนกลางภาคนะครับของก่อนกลางภาค15คะแนนแล้วก็หลังกลางภาค15คะแนนนะครับจะขอเปลี่ยนใหม่นะครับเนื่องจากว่าผมเห็นได้แค่ว่ามีใครวิวหรือไม่วิวนะครับที่ YouTube นะครับเนื่องจากคุณต้องการชัดเนาะมันไม่ได้อยู่ที่ Classroom นะครับก็ไม่รู้ว่าคุณดูจริงหรือไม่นะครับก็ดังนั้นจะขอเป็นสอบเก็บคะแนนสอบเก็บคะแนนก่อนกลางภาคนะครับ10คะแนนนะครับคือจะลดคะแนนในส่วนการเข้าเรียนตอนนี้ผมไม่ได้ฟังหูฟังนะครับผมจะไม่ได้รับข้อมูลจากคุณนะครับถ้ามีอะไรก็พิมพ์ทางไลน์หรือว่าโทรมาทางไลน์ส่วนตัวได้นะครับจะเป็นด่วนๆนะครับโอเคไหมเพราะว่ามันจะได้ขึ้นเตือนนะครับผมอาจจะดูตัวหนังสือไม่ค่อยทันนะครับที่จะแจ้งนะครับก็คือว่าลดคะแนนการเข้าเรียนนะครับจาก15เป็น5นะครับขออภัยที่เปลี่ยนแปลงนะครับเนื่องจากว่า2วันที่ผ่านมาผมถูกถูกปรึกษาอย่างหนักนะครับโอเคไหมถูกปรึกษาอย่างหนักว่เขามองเห็นว่ามันมีความความไม่คะแนนมันให้ง่ายไปนิดนึงนะครับแล้วผมก็เรียนแจ้งเขาว่าคุณไม่ได้เปิดกล้องให้ผมดูเลยนะครับดังนั้น15คะแนนก็จะไม่ค่อยคุ้มกันนะครับดังนั้นก็เลยขอลดลงมาเหลือ5นะครับแล้วก็10คะแนนก็จะเป็นอันนี้ผมต้องแจ้งคุณชัดเจนนะครับ10คะแนนจะเป็นการสอบเทสนะครับซึ่งก่อนกลางภาคเราก็จะสอบเทสกันประมาณ1ครั้งหรือ2ครั้งนะครับขอดูก่อนนะครับก็จะเป็นผมอยากได้เป็นข้อเขียนนะครับโอเคไหมผมไม่เอาช้อยส์นะครับเดี๋ยวผมเทสของผมก็คือเปิดโจทย์นะครับแล้วก็คุณแสดงวิธีทำนะครับเหมือนปริญญาตรีนะครับ แต่สอบกลางภาคปลายภาคก็ยังใช้เหมือนของโรงเรียนเหมือนเดิมนะครับก็คือว่าเพื่อว่าคุณจะได้เก็บคะแนนตามกฎของโรงเรียนนะครับเป็น choice นะครับของที่โรงเรียนนะครับแล้วก็ของที่เทสที่ผมอยากได้เนี่ยนะครับที่จะมีพิเศษขึ้นมานะครับก็จะเป็นแบบเขียนนะครับเป็นข้อเขียนนะครับล้วนนะครับไม่มี choice นะครับเปิดโจทย์แล้วก็คุณก็แสดงวิธีทำมาเดี๋ยวผมตรวจเองนะครับแล้วก็เมื่อเปรียบเทียบกับรุ่นพี่นะครับที่เขาไม่มีเทสนะครับเขาทำกันบ้านอย่างเดียวนะครับผมไม่รู้ว่าใครไปบ่นหรือเปล่านะครับว่าเยอะไปกันบ้านเยอะไปก็ เขามีคนติงมานะครับก็ผมก็จะลดแล้วกันนะครับ ไม่เหมือนรุ่นพี่นะ รุ่นพี่ที่เขาจะมีการบ้านทุกครั้งที่เรียนนะครับ พอมีโจทย์ทำบนกระดานปุ๊บก็จะมีการบ้านทันทีนะครับ อย่างที่คุณเห็นครั้งล่าสุด พอมีโจทย์ปัญหานะครับ คิดคำนวณปุ๊บก็จะทำเป็นการบ้านทันที แต่ว่าสำหรับคุณเนื่องจากเก็บคะแนนแค่ครึ่งเดียวนะครับ จากส่วนการบ้านนะครับ ปกติเขาจะเป็น30นะครับของปีที่แล้วครับรุ่นพี่คุณ ปีนี้เราเป็น15นะครับส่วนการบ้านผมก็จะลดความถี่ของการบ้านนะครับ โดยก็จะเป็น2วันต่อ1ครั้งนะครับ ไม่ได้เป็นไม่ใช่1สัปดาห์ไม่ได้2ครั้งเหมือนรุ่นพี่นะครับ ก็จะเป็น1สัปดาห์ที่เรียน2ครั้งก็จะการบ้านครั้งเดียวนะครับโอเคไหมก็ลดลงมาครึ่งหนึ่งตามนี้แล้วกันนะครับแล้วก็ถ้าเนื่องจากทำครึ่งเดียวนะครับคะแนนคิดครึ่งเดียวคุณก็จำนวนความถี่คุณก็จะจำนวนความถี่ในการทำกันบ้านคุณก็จะน้อยกว่าปีที่แล้วนะครับ ก็ครึ่งหนึ่งนะครับ1 อาทิตย์ครั้งเดียวนะครับ ในขณะที่ปีที่แล้ว1 อาทิตย์2 ครั้ง แล้วก็จะมีเทสขึ้นมานะครับ เพราะว่าดูคุณเช็คชื่ออย่างเงี้ยผมไม่รู้ว่าคุณดูจริงหรือไม่นะครับโอเคไหมครับ ก็แจ้งตามนี้นะครับ ส่วนใครเห็นไม่ไม่ใครเห็นเป็นอย่างอื่นนะครับคิดว่าเสนอในอย่างอื่นก็เสนอมาได้นะครับ แล้วก็ผมคงยังทำตามที่คุณต้องการเลยไม่ได้เพราะว่าต้องฟัง605เขาด้วยนะครับโอเคไหมครับก็หมดเรื่องหรือใครจะพูดมาตอนนี้เลยก็ได้นะครับโอเคไหมทางไหนดีจะให้ผมออนไลน์ที่ Classroom เพื่อฟังคุณไหมครับหรือว่านำเสนอมาได้เลยนะครับจะโทรมาทางไลน์ก็ได้ครับผมว่ายึดตามเดิมครับผมว่ายึดตามเดิมถ้ายึดตามเดิมคะแนนเข้าเรียน15มันก็ง่ายนะครับก็การบ้านก็จะสัปดาห์ละ1 ครั้งแต่ว่าแบบที่ตกลงกันไว้ครับก็คือผมต้องเห็นคุณไงว่าคุณนั่งเรียนจริงๆครับใช่ไหมครับถ้าจะเอา15แบบ15แบบที่ผมแจ้งวันแรกใช่ไหมที่เปิดมาแล้วพบกันวันแรกผมพูดซะยาวเลยคือผมก็อยากยึดตามนั้นแต่ว่าคุณไม่เปิดกล้องให้ผมยึดตามเดิมครับเห็นด้วยครับคือคุณไม่เปิดกล้องให้ผมเห็นไงผมไม่ทราบว่าคุณอยู่จริงหรือไม่อยู่จริงนะครับโอเคไหมแล้วก็ผมก็ยังเป็นกังวลว่าถ้าเทสเนี่ยคุณจะลอกกันด้วยผมจะขอให้คุณเปิดกล้องระหว่างเทสด้วยนะครับแบบทูๆแบบว่าผมไม่แฟร์สำหรับพวกเราครับก็คือผมก็อยากยึดตามเดิมนะครับ แต่ว่าถูกถูกกดดันจากผู้อื่นมานะครับ เพราะเขาทราบคะแนนเข้าเรียนแล้วเกิดเกิดประเด็นถกเถียงกันหรือเปล่านะครับ เพราะว่าเขาโทรมาปรึกษาผมเป็นการด่วนเมื่อวัน2 วันที่ผ่านมานะครับ จริงๆการเปลี่ยนคะแนนก็ไม่ใช่ไอเดียผมนะครับ เพียงแต่ว่าคนอื่นเขาที่เราเปลี่ยนมาเป็น YouTube เพราะอาจารย์หรือเปล่าครับก็ผมเรียนมิดแล้วมันไม่ใช่ครับก็มีก็ใช่ครับเหตุผลก็คือคุณบอกว่ามันไม่ชัดเนาะผมก็ทำทุกอย่างให้นะครับ ตอนนี้ iPad ไม่มานะครับ ก็วิธีเดียวที่ทำให้ชัดสุดก็คือตรงใช้ YouTube เพราะว่ามัน resolution ได้สูงไม่แน่ใจว่าได้รับข้อมูลจากโค้ชทิเชอร์หรือยังไงนะครับ แต่อาจารย์เป็นคนส่งคะแนนเข้าใจครับ ผมเป็นคนเรียกว่าอะไรออกแบบคะแนนทั้งหมดแหละ แต่คนอื่นเขาทราบเรื่องหรืออะไรสักอย่างนะครับ ก็พิมพ์มาได้เรื่อยๆความเห็นนะครับคือยังไงดีก็เดี๋ยวคือผมต้องแจ้งคุณอย่างนี้ไปก่อนนะครับ แล้วก็เดี๋ยวผมปรึกษากับอาจารย์ท่านอื่นคุณครูท่านอื่นนะครับอีกรอบหนึ่งแล้วกันนะครับ แต่ผมอยากให้เป็นไปตามเนี้ยก็คือเปลี่ยนเป็นเทสแล้วกันนะครับ คือ15คะแนนนะครับ ผมก็บอกวันแรกว่าอะไรนะดร.โชคสลันเขาให้เปิดกล้อง คุณก็ไม่เปิดกล้องเปิดคือคุณจะเปิดโดยทางมีด ผมก็จะเปิดมีดดูคุณนะครับ เพราะว่าผมต้องการเช็คว่าคุณอยู่จริงครับ คือเปิดโอกาสให้ง่ายที่สุดที่คุณไม่ต้องออกแรงอ่านหนังสือสอบเทสอะไรพวกเนี้ย แต่พอคุณไม่ยอมเปิดให้ผมไงครับ ผมก็ไม่รู้จะทำไง แล้วคราวที่แล้วก็เหลืออยู่แค่18 คนหรืออะไรจำไม่ได้นะครับ ห้อง605หรืออะไรสักอย่างครับ เหลือ18 คนนะครับ ผมก็เลยเกรงว่ามันจะไม่ค่อยสมน้ำสมเนื้อกับ15 คะแนนนะครับ จริงผมไม่อยากเปลี่ยนครับ แต่ว่าถูกคนอื่นกดดันมานะครับ ก็เลยต้องทำตามเงื่อนไขที่เขาต้องการครับโอเคไหมก็โอเคเดี๋ยวคุณปรึกษากับห้อง605ด้วยแล้วกันนะครับถ้าเปิดก็คือมันต้องทำ2 ห้องให้เท่าเทียมกันครับ จะมาเลือกห้องหนึ่งเทสเลือกห้องหนึ่งยอมเปิดกล้องแล้วคุณเก็บ15นะครับมันก็จะไม่แฟร์นะครับ คุณคุยกันแล้วกันนะครับ ถ้า605ยอมเปิดกล้องได้ทุกคนนะครับ คือคุณส่วนหนึ่งผมก็เกรงว่าคุณจะไม่มีอุปกรณ์นะครับ ก็คือพวกอะไรมือถือกล้อง แต่ผมว่าทุกวันนี้ทุกคนก็น่าจะมีนะครับ ก็ยึดตามนี้ไปก่อนนะครับผมต้องขออภัยนะครับที่เปลี่ยนแปลงผมก็คิดว่าจะเป็นเหมือนอย่างวันแรกที่ผมประกาศไป แล้วก็มีท่านอื่นเขาติงมานะครับเคมาผมก็ไม่อยากขัดผู้อื่นครับเคมา so let's get back to our we need to change to the laptop monitor, right? Let's get back to our story, which is in the topic of polarization of electromagnetic wave, right? We have just finished the problem about Malthus law, right? And that's the story about the calculation of the light intensity, right? And we have done an example, and so we are going to oh, I'm sorry, I didn't ขออภัยนะครับผมไม่ได้ส่งอะไรนะ lecture note อันเวอร์ชันใหม่ให้คุณนะครับโอ้ลืมนี่สำคัญมากนะครับโอเคมีเพิ่มขึ้นมานะครับรายละเอียดนิดนึงนะครับตรง it's a story aboutนะครับของตรงเนื้อหาตรงนี้นะครับผมเพิ่มขึ้นมานะครับให้มันละเอียดมากกว่าเดิมครับ yeah now I need to send as well to the M605 right okay okay it's all right then I have added some contents which is different from the former version, the last version of our lecture notes. So this is the additional detail because it's quite hard to get directly to the story about Snell law or the Brewster angle and so on. So we need to get introduction a little bit about the behavior of light. Okay, I'm not sure whether you have. I need to monitor what's going on in the live group. Okay. I hope that the voice and everything is fine, right? Okay, the light, if you, okay, before that, in also in engineering, in electrical engineering, we will consider the light as electromagnetic wave, okay, which is the main target here, the title of this chapter, right? Electromagnetic wave. So if you go further to the next subject in to the physics number 5, okay, which will be held in the next semester, the light can be considered as well as the a particle, okay, but here we are at the beginning step of the physics, so we will consider the light as electromagnetic wave, okay, which is our main target here in this chapter. The light can be regarded as having dual nature, okay. You can say the theory or the idea of light can be divided into classical, or you can say the old generation of physics. In the modern physics, they consider the light as the particle, okay, and we will talk about that later in the next subject in the next semester. So the classical theory about the light is governed, is controlled by electromagnetic wave, okay. We say classical electromagnetic wave theory provides adequate explanation of light propagation and of the interference effects. Okay. The four equations by Maxwell can be seen as the classical wave theory. Okay, which lies in the theory of electromagnetic wave. Okay, and in our story here in physics, because we need to deal with the propagation of light, and we would need to deal with some effects when the light travels to substance to matter and so on. And another idea for the light is that the physics, the modern physics, have to consider the some experiments. For example, photoelectric effects, okay, in and other interaction of the light with matter. Okay, in those scenarios, we cannot apply the electromagnetic wave to explain or to describe something with that. So the scientists or the physicists actually have developed some new theory that consider the light as particles. Okay, and simply speaking, they just consider it as photon. Okay, but it's not for us in this chapter in this subject. Okay, the light has a number of physical property, and some is related to wave, okay, and other properties with particles. So the light travels in a straight line path in a homogeneous medium. Okay, now we are approaching the story about refraction of the light. Okay, but from now on we consider the light as electromagnetic wave. Okay, the light travels in a straight line. Okay, if we have homogeneous, okay, a single type of medium, we will see the light as electromagnetic wave, and The strange thing or the difficult thing happens when the light encounters or faces with a boundary, okay, which is the boundary can be even plain or even rough surface. The boundary happens between two different materials. Okay, of course, in our environments there are many types of materials, so it can happen that the light can propagate through different or various kinds of materials. So when the light travels through a substance, it moves from an atom to another atom of the substance. This is the basic idea. Okay, we are going to see or develop the idea when the light propagates through two different materials or matters. Of course, you know that atom, even the transparent material, we still have atoms in those materials, right? It's not simply even the air. We still have the atom or the molecule of oxygen. So basically, atom is the fundamental thing for us to consider the behavior of the lights when it propagates. And as you know, the atom of substance can impede or obstruct the light, and this can this can make the time lapse, and the time lapse happens due to the absorption and the emission by atoms, and it will allow the light go further to the next atom, or it can even emit the light itself. Okay, and the time lapse depends on the particular structure of the atoms in each material. So if you have different kinds of materials, so there will be different time lapse, and that's the origin or the beginning state of our story here. Varies among several media. For example, if we take a look at this, okay, the wave starts from the gray area, and it propagates to the next material, which is represented by the blue one here. Okay, and of course, if you take a look at the E field, the electric field, okay, it has a sinusoidal waveform, right? As you have seen earlier in this chapter. The sinusoid has a constant wavelength. Okay, wavelength is denoted by lambda. Okay, let's say this is the first material, so everything will be denoted by 1. Okay, and in the green, in the blue area here, we are going to we will denote every quantities in this matter or substance as the number 2. Okay, the subscript number 2. The wave has the wavelength of lambda 1 in the first substance. And when it propagates to the next one, the next substance, it has a different value of wavelength. Okay, it's lambda 2. You can see that lambda 1 here is greater than lambda 2, but one important thing is that the frequency, how many cycles per time, okay, for both scenario, for any matter, for any substance, will still be the same, okay. The frequency of the wave of the light will be the same even it propagates through any different material or substance, okay. For example, in the first matter, the light has the same frequency as in the second substance, okay. And that's the key idea, okay. And N is what we will talk about later. N is actually the index of reflection, okay. And that's it in this figure, okay. They say the wave propagates from medium 1, okay, to medium 2, and it has lower speed. Do you know why it has lower speed? พอทราบไหมครับว่าทำไมคลื่นมันมีความเร็วลดลงAnybody can have an idea about the reason why they say that the light or the electromagnetic wave in this area has lower speed than this one? มีใครพอบอกเหตุผลได้ไหมครับ Any idea about that? Or should we believe in what they say here with lower speed from medium 1 to medium 2? If not, so I need to tell you. According to the principle, the substance, so in both scenario, in both areas, we still have the same frequency. And as you know, V is equal to lambda F, right? V is equal to lambda F if you, so I need to bring you to the Fantech, right? Laptop. Oh, you got a cam link. Okay. So I need to remind you to the fundamental formula, which is let's remind us the fundamental formula. V is lambda F, right? V is lambda F, okay, and in what happened? In this figure, in the first substance, we have larger wavelength, so larger wavelength than the second than in the second substance. So lambda 1 is greater than lambda 2, right? So we will have different value for the velocity of the light, right? So V1 is lambda 1 times F, okay, and V2 is lambda 2 times F, right? And please note that. Oh, I'm sorry for that. I didn't change. Okay. Please note that the frequency is the same. Okay, remains the same for both scenario for both substance, and as we know that lambda 1 is greater than lambda 2, right? So it means that V1 is greater than V2, okay? And that's why we say the wave, the light, okay, this is matter 1 and matter or substance 2, right? Okay, and here we have V1 and V2. We can say that V1 is greater than V2, and when the wave propagates in this, the light propagates in this direction, it has lower speed, so it becomes slower. Okay, and that's it. Let's get back to our figure. อ๋ออาจารย์ห่างจากไมค์แล้วไม่ได้ยินครับถูกต้องครับผมเปลี่ยนเป็นไวเลสให้ที่ติดตรงคอลืมเปลี่ยนให้นะครับโอเคไหมI'm sorry for that จะพยายามไม่ลืมนะครับโอเคlet's talk about our lecture notes. Okay, when a ray of the light traveling through a transparent medium, and then if it encounters a boundary, part of the ray is reflected, and part of the ray enters the second medium. So that's the figure you have seen in the whiteboard. The figure you have seen in the whiteboard is quite simple. Okay, it's quite simple. There is no reflection. We don't talk about reflection, but there is only the effect that we consider the propagation that passes through the second medium. Okay, the second matter. But in the next scenario, we will cause the complete effects that happens in reality or in nature. This one, okay. In this figure, this is the input light. Okay, it starts from this one. Okay, this is just a ray of light. Okay, they just control the source of the light so that the light can have fully can pass through a single hole. Okay, and that's why you can see a simple a single ray like this. Okay, and okay, let me say this is the lucite block. Okay, it's a transparent medium. So the source emits the light, a ray of light. Okay, and as you know, the light propagates through the air. Okay, this area is the air. Okay, this block is surrounded by the air. So the first matter for us in this scenario will be the air. Okay, and of course this is the smooth surface. Okay, smooth plane, and there will be a boundary. Okay, because there is the boundary between the air and the lucite. Okay, and we have a plane here which is flat or planar. Okay, and the light can go further to this matter, which is lucite, and this one will be called reflecting component or reflection component or reflected component. Okay, but this one is called reflection or reflecting components or reflected components. Okay, there are two ways for the light to travel further. Okay, and you can see that the intensity of the light is lighter. Okay, it's not as strong as the input side. Okay, and the reflecting component will not be absolutely a single ray. Okay, because this matter is not an ideal. Okay, so there is some reflecting components more around this, but in theory we would consider this one as a single ray. Okay, and if you go further, what is the reason why we have the fourth and the fifth components? Yeah, this is the first component, this is the second component, which is reflection, which is due to reflection. The third component is due to the reflection. Okay, ภาษาไทยเรียกว่าสะท้อนนะครับอันนี้สะท้อนอันนี้เรียกว่าหักเหหรือว่าหักเหนะครับภาษาไทยเรียกว่าอะไรนะครับไม่เหมือนไม่เห็นอีกจอใน YouTube ไม่เห็นอีกจอใน YouTube อีกจอใน Oh, I'm sorry for that. I forget to transfer. Sorry for that. I'm sorry for that. Thank you very much. Okay, so I need to explain again. This is the first component. Okay, I'm sorry for that. This is the first component. This is the lucite block. The person who make the experiment just give the hole. Okay, and there will be a source of light, the red light, and the light passes through a single hole. Okay, that's why you see a single ray of the light. Okay, and around the lucite block you have the air. Okay, this lucite block or cubic, you can say, is surrounded by the air. Okay, everything is surrounded by the air, and they just leave the lucite, okay, on something, okay, some matter, and of course the light needs to go further, and the lucite is a transparent medium. Okay, transparent means the light can propagate through it. Okay, and there will be two ways for the light to go ahead. Okay, the first one, which is the second component of the light here, is this one, which is the reflecting component. Okay, and this one is another component which is caused by reflecting or reflection. Okay, reflecting component. Okay, and you can see that the intensity of the light here is lighter. Okay, it's not as strong as the incoming side. Okay, and you will see another ray here, and it's not really or absolutely a single ray. Okay, the ray is a little bit thicker or brighter because the molecule of lucite may not be an ideal case, so the light becomes a little bit brighter here. And at this junction, at this boundary, it is the place where the air touches. จอใน YouTube เล็กมากครับ ผมไปที่จอใหญ่แล้วหรือยังครับ ผมไปที่ ผมเปลี่ยนแล้วนะ เปลี่ยนไปที่เอ่อเปลี่ยนไปที่สไลด์แล้วนะครับ ทุกคนเห็นไหมเอ่ยไอ้ที่ผมอยู่ที่สไลด์แล้วนะครับอันนี้เน็ตค้างเลย Okay. We are live at this point, right? And we can see that there will be a barrier between the lucite and the air again. Okay, so this is another line, which is the barrier between two metals again. And of course, the light should go further through the air. It's also possible, but I guess that they just leave a matter here. So there would be a piece of base or something like that. So we cannot observe, and there will be reflection again. Okay, because there is a barrier between. Okay. This is another battery. It's a battery between lucite. This one is not air. It's a base. It can be stone or wood or steel or something like that. So the light cannot go through the. This one is not a. This one is not a transparent medium, so the light cannot propagate through it. But this will be the reflecting component again. Okay, reflecting components, and here is another place where we can find the boundary between the lucite and the air, and this component is reflecting component again. And actually, there should be reflecting component. Okay, but the intensity of the light here is already not high, so it's really hard to observe the reflecting component. Okay, but at least you understand how the light behaves when there is a junction. Okay, the boundary between two substances. Okay, the ray that enters the second medium is bent at the boundary and is said to be reflected. Okay, and you can see here. Okay, this one is better to see. This is the incident light. Okay, let's say this is the air and this is the glass. Okay, lucite can be considered as a type of glass, and usually the incident ray should be like this, right? Should be in this direction, but it is bent a little bit towards the normal axis. This is the normal, okay, the normal axis, which is 90 degrees with respect to the surface of the boundary between the air and the glass. Okay, if you measure the angle between this vertical line and this line, okay, you would get 90 degrees, and this one doesn't go in the straight line. Okay, according to the next section of the next part of this line, and this is the reflecting component or reflected ray, and this is the reflected ray. โอเคอันนี้ส่วนสะท้อนนะครับอันนี้ส่วน ส่วนหักเหหรือส่วนเบี่ยงเบนครับผมไม่รู้ว่าภาษาไทยเรียกว่าอะไรวีรพัฒน์จอใหญ่แล้วนะครับโอเคไหมจอใหญ่ให้แล้วนะครับถูกไหมเอ่ยมีอะไรแจ้งมาได้เลยครับไม่ถูกใจเสียงไม่ดีอะไรแจ้งมาได้ทันทีนะครับถ้าชัดเจนจริงๆโทร YouTube มาส่วนตัวนะครับเพราะไม่ใช่โทรทางไลน์นะครับเพราะว่าบางทีผมก็จะไม่ได้ดูตัวหนังสือนะครับโอเคwhat next we need to go further in here in figure 35 I'm sorry for this line this thing should be here in figure 35 which is this one the angle of refraction this is the angle of refraction which is denoted by theta 2 okay this is theta 1 this is theta 1 dash okay and we will talk about it later about the regarding the theta 1 dash okay this is the all the angles here all three angles are measured from the normal axis okay normal ก็คือแกนที่มันตั้งฉากกับเส้น boundary นะครับเส้นขอบของ2เนื้ออันนี้นะครับ2เนื้อของสสาร the angle of refraction theta 2 depends on the property of two media and on the angle of the incidence which is theta 1 okay they said theta 2 depends on theta 1 okay and depends on the property of two matters which are air and glass okay so some people have found the relationship and it can be expressed like this okay it's okay sine theta 2 divided by sine theta 1 equals v2 by v1 okay it depends on the speed of the lights in both substances okay what else there is an internet connection problem there as the light travels from a transparent medium to another its frequency does not change okay as I told you and when the frequency doesn't change we will explore some relation okay between those two scenarios two matters or two substances v1 is lambda 1f okay and v2 is lambda 2f according to the general expression of the velocity or the speed of the any wave right and you can see that in both methods f will be the same okay the frequency doesn't change and if you move lambda to the left hand side of this equality of this equation you get v1 by lambda 1 right and if you move lambda 2 from the right hand side to the left hand side of this equation you will get v2 by lambda 2 right so it's better if I do it for you in on the whiteboard okay and then I have to change the microphone as well นะครับย้ายมาที่กระดานนะครับทำให้ดูเดี๋ยวใช้ใช้สไลด์แล้วคุณอาจจะตามไม่ทันนะครับผมใช้คำพูดครับก็สดๆอย่างนี้แล้วกันครับ with the same equality I hope that you can hear me right you can hear me เดี๋ยวนะครับขอจัดการนิดนึงครับอินเทอร์เน็ตไม่ไหลนะครับoh what happensแป๊บนึงนะครับผมไม่สามารถมอนิเตอร์ได้นะครับว่า YouTube เกิดอะไรขึ้นนะครับอินเทอร์เน็ต เน็ตไม่ไปนะครับอันนี้ it's still excellent condition right on this land this one okay okay and then okay it goes right now okay as you know V1 is it acceptable to you okay V1 is lambda 1 F and V2 is lambda 2 F right and with this oh yes it's still acceptable here you can have F is V1 by lambda 1 right and again with this equation you can derive that you can see that V2 by lambda 2 is equal to F okay and in both scenarios in both medium the frequency doesn't change okay F is F the same okay F1 and F2 are the same so you can make them to be equal and that's why you get V1 by lambda 1 equal V2 by lambda 2 okay and it's what you get okay in equation number 33 you get finally you move V2 to the left hand side you move lambda 1 to the right hand side you will get V1 by V2 equals lambda 1 by lambda 2 okay it's quite straightforward it's not too difficult to understand okay now we get back to the lecture notes againพี่เทไทยปวิน6โอเคพิมพ์ชื่อใช่ไหมครับโอเคso you can arrive at the equation number 13 right in the index of refraction of an optical material now we will talk about the index of refraction of any matter okay any transparent medium and as you can see before we have seen N1 right N1 N2 N1 and N2 are actually the the indices of refraction okay and it's somehow like this okay index of refraction of any transparent material it is also known as reflective index and they usually use the letter N okay to represent this index and this index it plays a central role okay? It's an important thing in geometric optics and we will talk about that later geometric optics the index of refraction of an optical material is the ratio of the speed of the light in the vacuum, denoted by C. Okay, that's the speed of light that we have seen before, right? In this is the value developed by Heinrich Hertz, right? I have said before. This is the numerator, okay, and this one is the denominator. The denominator is the speed of light, okay, in a material, okay, which is not vacuum, and we represent that speed by the letter V, okay, and the ratio can be simply written as equation number 14, okay. N equals C by V, okay. C is the speed of the light in the vacuum, and this is the speed of the light in that material, any material that you want to investigate, okay. And N will be different for will be different for several materials. Let's take a look at some of them, okay. This is the name of the substance, and of course any metal can be in three phases, right? In three form. The first form is solid, the second one is liquid, right? And the last one is gas, okay, gas state. In the solid state, we would have diamond, fluoride, fused quartz, okay. This is the chemical formula for those substances. One thing I would like to mention, the index of refraction is unitless, okay. It has no unit, okay. And what happens? It's unitless, okay. It has no unit, but this one is meter per second. And one important thing is that the value of N should be always greater than 1, okay, because the light cannot be faster than the speed in the vacuum, okay. Any matter will of course vacuum means it has no molecule of any atom at all, so there is no obstruction for the light to propagate. But if you let the light go through a matter, any spatial matter, of course in that material there will be atoms, right? And the several atoms of those matters or materials will obstruct the propagation of the lights. So it's impossible that the light will be faster than its propagation in the vacuum, okay, because the atoms of that substance tries to obstruct the light. So the speed of the light in any matter, in any substance, okay, except for the vacuum, will be slower, okay, will be less than the speed in the vacuum. And what you can see is the following here. The indices or the indexes, okay, indices is in Latin plural form. The indices of most materials will be greater than 1, okay. It's 2.4, 1.4, 1.4, okay. You can see everything will be greater than 1, and the least amount of obstruction can happen when the matter has very small number of atoms, and it will happen in the gas state, okay. For example, the air contains nitrogen 80%, and it contains oxygen or 16% or something like that, okay. Because there will be less amount of atoms to obstruct the light, so the index of the index of refraction will be very close to the speed. Will be close to 1. Okay, the speed of the light in the air will be close to the speed of the light in the vacuum, as same as carbon dioxide. Okay, because this is a type of gas. Okay, and in our calculation in the next in the sequel in the next slides, we will approximate the index of refraction of the air by 1. Okay, we can say it's approximately 1, but actually it's not absolutely 1. Okay, it's 1.00239. Okay, but when the atoms of that matter stay very congestive, for example diamond, there will be much obstruction, okay, by the atoms of diamond, so the light cannot propagate easily, so there will be much obstruction. That's why the index of refraction here is high. Okay, so this is the table which is measured by using the light in the vacuum of the wavelength lambda equals 589 nanometer. You can see that it's taken from the book number 3. And let's take a look at the table. It's the same thing, but it's taken from a different book. Okay, it's book number 4. And this is for the water. Okay, 1.3. And okay, the first state is solid. The next one is no, it's not gas. It's glass. Okay, they didn't provide the index of refraction for the gas. Okay, it has only 2 states, solid and liquid. Okay, if you do the homework or you want to take the value of index of refraction, you can take a look at both tables. Okay, as I mentioned before, the value of the index of refraction or the refractive index is always greater than 1 here. Okay, and actually the light with 589 nanometer is the yellow sodium light. Okay, that's the name for that, for the light of this wavelength. And you can derive a little bit. Okay, in terms of reflective indices. Okay, so let's get back to what time is it? Okay, we still have much time. Let's get back to the whiteboard. Okay, นี่ดูหน่วงๆไว้นะครับ Let's get back to the whiteboard. You arrive at this relation, right? You arrive at this equality, and I need to show you according to the definition of the refractive index, N is C by V, right? And the same thing, we have 2 methods, we have 2 substances, 2 media. So in the first media, we would have this value. Okay, N1 is C by lambda 1. Okay, please note that this is not the speed of the light in the first matter. This is the speed of the light in the vacuum. Okay, it's a constant for any matter. Okay, the index of refraction is a ratio between 2 velocity or 2 speeds. It is defined with respect to the speed of the light in vacuum, which is 3 times 10 power 8. So this one, the numerator, is only a constant. Okay, it holds the same value. Okay, the same value holds for any matter. And in the second matter, we have something similar, which is N2 equals C by V2. Okay, and you can change a bit because we have on the left hand side V terms, right? The terms of V. In this one, you can say that it can be written as V1 equals C by N1. Okay, and this one, for the second method, we have V2 equals C by N2, right? We have C by N2. I hope that you can see it, right? Okay. And now we will try to see the ratio between V1 and V2. We divide this equation by this equation, so we get so from this blue equation, V1 by V2 will be C by N1 divided by C by N2, okay? And it's actually C by N1 times N2 by C, right? And I hope nothing wrong. Okay, and C can cancel each other. Finally, we get N2 by N1. Okay, and V1 by V2 is actually N2 by N1. So this is our final conclusion. N2 V1 by V2 is N2 by N1, and that's why we get the result in equation number 15. Okay, equation number 15. Okay, we get this ratio, okay, as the final result. งงว่านี่มันทำไมเขาไม่ติดนะครับ Nothing happens. Okay, it's all right. We get the final ratio N2 by N1. Okay, for V1 by V2, and we will still need to use this. Okay, it's not final result. So let's start our principle regarding geometric optics. Okay, if you study physics, you would need to deal with the story about optics. Okay, optics is the main society, and in engineering, for me in telecommunication engineering, optics play a central role in high data rate communication. And as you know, the high-speed internet now is transferred by fiber optic. Okay, if you know something about optics, you can work for several internet service provider. Okay, because we use optics to transfer the data even at your home. Okay, here we consider the model first. Okay, there are three rules, three properties for the geometric ผมอยู่ถูกนะครับอยู่จอถูกนะแล้วก็ไม่ถูกนะครับ first we need to consider our agreement. Okay, we need to talk about our agreement. It means the model. Okay, we have the first substance, which is substance A or substance number 1 is the same thing, and the second substance, which is the matter B or the substance B, okay, A is equivalent to number 1, B is equivalent to number 2, okay. And of course, this is the boundary, right? This is the plane, the smooth surface. Okay, we will not talk about the non-smooth surface of two substance. Okay, and that one is it's scattering effects. Okay, it's not reflection at all. Okay, it's scattering. It's something different. We will talk about only the boundary that has a smooth surface. Okay, and that's why we have a straight line here. And with this straight line, of course, there will be a normal line, okay, which is 90 degree from the boundary line here, okay. And we have the incident ray, okay, the incoming ray actually. And any angle, okay, in this story, in this topic, will be measured from the normal. And of course, as you know, this is the normal. So the angle of the incident ray will be measured from the normal to that ray, okay. And that's why we have here theta A. We say theta with subscript A because this is the angle at the substance A side, okay. And of course, when the light arrives at the boundary, there will be two ways for the light to propagate further, right? The first one is the reflecting component, okay, which is the reflected ray here. And of course, the reflected ray should be measured with respect to the normal. So you start from the normal and nothing wrong happened? Anything wrong? Okay. And you measure the reflected ray from the normal here. You start from the normal and measure to the reflected ray, okay. It's denoted by theta with subscript R, okay. R stands for reflecting components, reflected ray, or something like that. And the second way for the light to travel is the reflection, okay. And as you know, the lights can go further into the second medium, which is the substance B. And of course, these rays can be measured. And the measurement should be made with respect to the normal as well. And we would say this is the theta with subscript B. You know, the reason why we say subscript B, because it's in the B side. It's in the substance B side. Okay, and that's why we say theta B. So, you understand now, this is the model of the principle of geometric optics. Okay, and there will be three rules about geometric optics. First thing, the first rule is the incident, the reflected rays, okay, all these three rays, the first ray, the second ray, the third ray, and the normal to the surface, okay, this is the normal line with respect to the surface, okay, the connection line of these two matters, two substances, okay. 1, 2, 3, and 4 lines, okay, are in the same plane. That's the first rule in geometric optics. Okay, you understand? And this line is called, I cannot remember. It's called plane of incidence or something like that. We will talk about that later. Okay, that's the first rule. The 4 lines. The first line, which is the incident ray, incident line, the reflecting line, and the normal line will be in the same plane, okay, in the same planar surface. So let's talk about the second rule in geometrical optics. The angle of the reflection is equal to the angle of the incidence for all wavelengths and for any pair of substances. Okay. This property doesn't depend on the wavelength of the light or electromagnetic wave. This property doesn't depend on the matter properties of any substance, of any pair of those two substances. Okay, the equation can be generally written as theta reflection equals theta incidence. But in this scenario, in this figure, in this model, theta A, which is the incident angle, and theta R, which is the reflecting angle, will be equal to each other, which is this one. Okay, theta R is equal to theta A. Okay, the incoming angle is equal to the reflecting angle. Okay, that's the second rule in geometrical optics. Okay, before we go ahead, we need to talk about the rules. Okay, it's like you want to if you want to go for boxing, for example, you need to know the rules how to box on the stage, right? It's the same thing here. Before we calculate or do some calculation about geometrical optics, you need to know the rules. That's the first two rules. Okay, the first rule is that all those three lines will be in the same plane, and in the second rule, the reflection angle is equal to the incident angle. So that's the second rule. Let's talk about the third rule, which is the most complicated one. Okay, but it's not beyond our ability to understand. In the third rule, there will be a law of refraction, which seems to be discovered by this person, widely brought Cornelius, but it's not so widely known. You may have ever heard his popular rule, which is called Snell's law. Okay, have you ever heard that? เคยเจอมาก่อนไหมครับคำนี้อาจารย์ครับสะดวกไหมครับผมสอนอยู่ครับคุยเลยตอนนี้ Okay, I'm sorry for that. Someone has told me about the rule for your formative scores. I'm sorry for that. But he's quite important person, so I need to stop the explanation to you. I'm sorry for that. So let's go ahead. This rule might be a well-known law to you. Okay, maybe you have ever heard that. Anyway, we need to remind ourselves เคยเจอไหมครับคำว่า snail law นะครับเคยกฎของนาย snail เคยผ่านไหมอยู่ม.4 ม.5 เคยผ่านไหมครับถ้าผ่านมาแล้วผมก็จะข้ามนะโอเคมาokay, in order to derive the result by snail law, which is quite widely known, okay, we substitute what we get before. Okay, v1 by v2 is equal n2 by n1, or you can say a means the first substance, b means the second substance, and this is the n2, right? It's equal to nb, and this is a. I hope that you will not get confused, okay, when we change the subscript from number 1 and the letter A, number 2, the letter B, okay. This is the reason why we have different notation is that I have taken the stuff from 2 different books, okay, so that you can completely understand the theory, okay. That's it. It has nothing to do with the alphabet, the subscription, okay. The theory will be the same, okay. You get a broad idea about the theory. Okay, this is the result we get from the whiteboard, okay, right? Here the results we get from the whiteboard, which is v1 by v2. Okay, v1 by v2 is equal to n2 by n1, okay. And if you change the subscript 1 by a, 2 by b, you will get the same thing in the lecture notes, okay. We still have time, right? 21. Okay, and please don't forget that we have this relation, okay, in equation number 12. In equation number 12 here, sine theta 2 by sine theta 1 equals v2 by v1, okay. If we change the subscript from 2 by b, 1 by a, okay, we replace number 2 by the letter b, we replace the letter the number 1 by letter a, we would get this one, right? We would get this expression, okay. And if you substitute va by vb to the right hand side, you will get this thing, okay. I'm not sure whether you can completely understand. I will พอเข้าใจนะครับเดี๋ยวผมเขียนบนกระดานให้ดูก็ได้ okay, let's get back to the whiteboard. Okay, we have this one. Oh, no, I shouldn't remove that. เสียงถูกต้องนะครับอยู่ที่อันนี้นะครับ Okay, I will make a clear up a substitution to you so that you can see the idea why we get the snail law. Okay, again, this is matter number 2, or the second matter, v2, right? We have the relation, this one, va by vb is nb by n2, nb by na, okay. va by vb equals nb by n A, right? Please note that n is the index of refraction, right? Index of refraction. And what else? Next thing is another relation, which is the formal relation, psi theta b equals psi theta a equals vb by va, right? v by va. And our target is that we need to represent this ratio by the ratio of indices of refraction. So we have the on the right hand side here VB by VA, right? But this one is VA by VB. So in this equality, we just flip up, okay, move the denominator to the upper part, okay, to the numerator. So we get VB by VA, right? And again, the same thing on the right hand side, we have VNA by NB, right? So you can see that the left hand side now becomes VB by VA. Okay, is there anything wrong? เสียงได้ยินนะครับ VB by VA and the right hand side is NA by NB. So we will replace this one, okay? This one. We move this one to we replace the black one by this blue one, okay? So we get finally NA by NB, okay? We get this relation. And Snell says that he would like to move, he doesn't want the ratio, so we move NB to the left hand side. It's going to be NB psi theta b equals, okay, we are going to move the denominator of the left hand side to the right hand side. Now we don't have NB anymore because we have moved it to the left hand side already. So we get NA psi theta a as well, okay? So we arrive at this equality. We arrive at this equality, which is a Snell law, okay? And that's what you have in equation number 17. That's what you get in equation number 17. Okay, it's the same thing. Okay, but I have shown you in details in the whiteboard. In the whiteboard, okay, it's the same thing. Now we will arrive at the how to calculate the reflection angle, right? Which is the Brewster law, okay? One important thing for the next story is that the unpolarized light can be partially polarized by reflection, and we arrive at this model. But I think we have only 3 minutes left, right? So what we have learned today, I think I would leave this story to the next lecture, because it's a long story. If I start now, I need to introduce you again, because I need to remind you. Well, 2 minutes, and we need to leave this lecture at 10:10, right? Soก็เรื่องเก็บคะแนนนะครับการเก็บคะแนนก็จะยังค้างไว้นะครับว่าดูเหมือนว่าจะเป็น objection นะครับจากคุณนี่แหละครับก็คือคุณไม่ยอมรับเนาะใน ในการเทสนะครับก็ ผมก็ต้องขอให้คุณทำยังไงก็ได้นะครับให้ผมรับทราบว่าคุณเข้าเรียนนะครับเพราะว่าตอนนี้เท่าไหร่ current view is 23 people right now 23 people in อ่าก็ถ้าไม่อย่างนั้นนะครับก็คงเป็นเดี๋ยวเราจะจบแล้วนะครับ9 นาทีแล้วก็คงเป็นคุณต้องหาทางเปิดกล้องให้ผมเห็นครับหรือไม่อย่างนั้นคุณก็ต้องทำอะไรรีพอร์ตรายงานแล้วกันว่าเข้าเรียนแต่ละครั้งคุณจดอะไรบ้างครับแล้วส่งหลักฐานนั้นมาให้ผมดูนะครับผมจะประเมินว่ามันมันตรงจริงหรือเปล่าครับที่เรียนจริงๆนะครับโอเคไหมบางทีคุณเข้าพิมพ์ชื่อเปิดแล้วคุณก็ไม่ได้นั่งฟังเนี่ยคุณก็ผมก็ไม่รู้ว่าจริงๆแล้วคุณฟังคำอธิบายอยู่หรือไม่นะครับโอเคไหมคือคำว่า attendance ไม่ใช่แค่เปิดแล้วก็ทิ้งแล้วก็หนีไปนะครับโอเคso I would be on time okay straight light on time so it's 10:09 see you on next Wednesday right there will be no homework according to the policy to have half working load for you okay because we collect only half the the homework points sorry ปัญญานะครับโอเค see you on Wednesday สวัสดีครับบ๊ายบายครับ604โอ้โอ้โอ้ 604 Okay, let me change a little bit so where we are now. Okay, this one. Let me change a little bit. ขอแก้นิดนึงนะครับลืม full stop นะครับแล้วก็คำใต้ชื่อนะครับหลุดนะครับ Where is that full stop other particle other with party other with particle full stop full stop right. Okay, and this one the light propagation pro. Okay, this is 3, let's say.